Bismillah. Today, topic is about equation of motion, normal and tangential coordinates. So today objective, student will be able to apply the equation of motion using normal and tangential coordinates. Okay, this is one of the application in this topic. Race track turns are often banked to reduce the frictional forces required to keep the cars from sliding up to the outer rail at high speed. Okay. If the car's maximum velocity and minimum coefficient of friction between the tires and track are specified, how can we determine the minimum banking angle, theta, required to prevent the car from sliding up the track? Okay, if you see here, there is some kind of angle. We say this angle as the banking angle. So the banking angle is the one that prevent the car from sliding up because due to its speed. So that's why if you see every race track during the cornering part, they will have this kind of mechanism. Alright, another application. This picture shows a ride at the amusement park. The hydraulically powered arms turn at a constant rate, which creates a centrifugal force on the riders. So we need to determine the smaller angular velocity of cars A, this is the cars A, and B, such that the passengers do not lose contact with the seats. What parameters are needed for this calculation? Okay, once the rider is inside this car, either car A or B, they will fasten a seat belt, but to reduce the potential of them coming out from the seatbelt and cause injuries, there is some kind of smaller angular velocity that we need to achieve so that they are not coming out from that seat. So this is the other application. Okay, another application is about the satellites. Satellites are held in orbit around the Earth by using the Earth's gravitational pull as the centripetal force. Okay, the force acting to change the direction of the satellite's velocity. Knowing the radius of orbit of the satellite, we need to determine the required speed of the satellite to remain this orbit. So what equation governs this situation? Okay, if you see this is the Earth, I would say I have satellite A here. Why we put satellite A here is actually the same satellite A and B, just the position. So where is the position A, in which RA I measure that from the center of the Earth. For example, RA equal to 20 megameter. So it travels with VA around this orbit, and when it reach point B, I would say this is RB as well, 80 megameter. Okay, the same, I will measure the VB when it is at this position. Okay, so it means that we need to control VA and VB so that the trajectory is in this elliptic motion. Okay, we say this is elliptic motion. So we control, how could we remain in the position is by controlling the velocity. Okay, this is normal and tangential coordinates. When a particle moves along a curved path, it may be more convenient to write the equation of motion in terms of normals and tangential coordinates. Okay, be aware that before this we learn about about rectilinear motion, but this is about the curved path. I would say like this one. This is a particle P, for example, it's travel from here along this line until it reach here. For example, if I want to analyze at this instant, so I would say point P is somewhere over here. Okay, the normal direction N, I would say normal direction indicated as N, this one, always points toward the path center of curvature. In the circle, the center of curvature is the center of the circle. Okay, if I take this point, I need to analyze which curve is it. Inside this curve, if you extend this curve, you will say this as a circle, as this one. So every circle, it has its own center of curvature. It's just like imaginary cycle, imaginary circle. But here, when you analyze at this point, normal direction is always points towards this path center. If I take, for example, if in another case, I want to analyze P at this point, I would say this is my curve. Okay, can you see this? This is my curve. So my direction now, the normal direction, since it is always points towards the center path, center of the curvature, means that I need the point O as the center of the curvature would be somewhere over here. So when I plot this here, N will be in this direction. Okay, pointing towards the center. So since now P, this is my center. Okay, the tangential direction T, okay, now we are talking about T here, tangential, is tangent to the path, usually set as positive in the direction of motion of the particle. Okay, if the P is traveling from here to here, we know that the direction is pointing in this direction. So this one will be positive in this direction. So tangents means if I analyze this 90 degree, this will be coincide with this point. So I know that it will be the one that in line in this position. So T will be in this direction. So here we just introduce N and T, N for normal and T for tangential. Okay, since the equation of motion is vector equation, we know that based on the second Newton law, Newton's second law, summation of F equal to MA, in which we learn in chapter 13.1 until 13.3, and then later we analyze that in rectilinear motion 13.4. Now, actually we can use the same formula for the curved linear motion in the curved path. So vector equation summation of F equal to MA, it may be written in the term of the N and T coordinates as this one. Summation of FT, UT is the unit vector, equal to MAT. Which you see here, summation of F, which is related to the tangential axis, must be equate with AT, the acceleration in tangential direction. The same applied for summation of Fn, Un equal to Man. Okay, here F summation Ft and An are the sum of the force components acting in the T and N directions respectively. Means that this one will be equate with this, and then this one will be equate with this one, this term. Okay, this vector equation will be satisfied provided the individual components on each side of the equation are equal, resulting in the two scalar equation summation of Ft equal to Mat and summation of Fn equal to Man. So the same practice, actually we can separate this portion. This is everything is in. If you put everything in one equation, everything will be in terms of vector, right? But now actually you can separate this and this as a scalar form. So we have ft equal to mat and summation of fn equal to man. Okay, now this is only before this we're just talking about two axes n and t. But since there is no motion in the binomial direction, okay, if you take a look at this binomial direction, this one is outer plane. Before this we're just talking about this plane. But now if you take another perspective or another angle, 90 degree from the plane that we analyzed before, I would say I have another axis. We said B. B is binomial direction. So basically, if in this topic we just analyze that in two direction, n and t, because this one will be very complicated if we put the particle is travel along the axis in another plane. But since this is our assumption, since there is no motion in the binomial direction B, we can also write summation of fb equal to 0. That's why if you see there's another term here, summation fb ub equal to nothing here, because there is no value for fb, no traveling. The particle is not travel along this plane. That's why. Okay. So this is the acceleration. How we can estimate, or how can we measure or calculate the normal and tangential acceleration? The tangential acceleration, we always denote that as at, is actually dv over dt, because it is in the slope. If you see in this figure, at is actually on t direction, and it is actually a slope here. That's why we said how to calculate this is through dv over dt. Alright, what is dv over dt? dv over dt is actually the changes in velocity with respect to changes in terms of time. That's why we can analyze for at. Represents the time rate of change in the magnitude of the velocity. Everything that relate with time, we say that as time rate of change. Okay, depending on the direction of summation of ft, the particle speed will either be increasing or decreasing. Because if we discuss about the application in the satellite, there is at some moment the satellite must be speeding up. But for example, if I want to travel from here to here, I need to speed up the satellite so that it will always in this trajectory. While, for example, if here I need to reduce the speed so that it will slowing down the satellite motion, and it turn into a curve until it reach B. Okay, that's the reason why we need to control the speed. Okay, like I say, the particle speed will either be increasing or decreasing based on our needs. If I need to increase the speed, I need to burn more fuel, and then it will just produce a thrust, or else I need to reduce so that it will slow down in the trajectory as well. Okay, the normal acceleration, like we discussed just now, an. What is an? An is the normal acceleration. If we recall back this figure, n axis is always pointing towards the center of curvature. Alright, how to calculate an? An is actually equal to v square. V is the velocity divided by rho. Rho is the radius of the curvature. Represents, okay, an is actually represents the time rate of change in the direction of the velocity vector. Remember, an always acts towards the path center of curvature. Thus, summation AFFN will always be directed towards the center of the path. Okay, recall if the path of the motion is defined as y equal to fx. The radius of curvature at any point can be written from rho equal to this equation, 1 plus dy over ds square in bracket 3 powered of 3 over 2 divided by second derivative of dy over dx. Okay, this symbol is actually a modular symbol in which this one will be positive. Whatever value here, if you get a negative slope, because y could be represented in negative equation, and then if you do the second derivative, you might get negative value as well. But here you just put that as positive because we want to measure the rho. Rho is the radius of curvature, so this one will be positive. Okay, if you see here, dy over dx is actually dy over dx is, if I put y in terms of x equation. Okay, y measure, and then this curve will be in terms of x. So you can always, if a question asks you and then they just give you the equation, so this is how you calculate for rho. Okay, once you know the rho, you can just directly put that in this value, in this equation rho. So v is the instantaneous velocity at that point. Okay, so solving problem with anti-coordinates. Use anti-coordinates when a particle is moving along a known curved path. Second, you need to establish the anti-coordinate system on the particle. Okay, don't forget this part. This part, student always forget here. Draw free body and kinetic diagrams of the particle. The normal acceleration an always act inwards, the positive and direction. So towards the curve, towards the point of curve, center of the curvature. And the tangential acceleration at may act in either the positive or negative t direction. Okay, then you need to apply the equation of motion in scalar form and solve. So it may be necessary to employ the kinematic relation as well in this form, at equal to dv over dt. Remember, this is the slope at of the particle at instant. Then dv over dt is actually v dv over ds. Okay, this one is actually a derivation that we did in chapter 12. Okay, an is always v square. V square is the instantaneous velocity at the point divided by rho, radius of curvature. Okay, let's take a look at this example. Given here, the 10 kilogram ball has a velocity of 3 meter per second when it is at A along the vertical path. Okay, this is my ball. This is the position A. It is traveling at 3 meter per second. So you need to find the tension in the cord and the increase in the speed of the ball. Okay, I have it. The ball is actually attached to a cord here. So this is the center. And actually, if you see here, it is traveling along a curved path. Alright, the plan. Since the problem involves a curved path and requires finding the force perpendicular to the path, so here it will be good for you, or this one will be the best to use anti-coordinates. Okay, before this, what we learned in the previous chapter 13.4, we use that as rectilinear motion. So we use x and y direction. But here is a little bit different because it is involve a curved path. So curved path is best to use this coordinate system, NT, normal and tangential. So you need to draw the ball's free body and kinetic diagrams. The same, summation of F equal to MA. If you want to compare with the previous chapter, we have summation of F in the previous chapter, 13.4. We use summation of F in terms of how many axes that you have, X, Y, for example. You need to equate with MAX or MAY. But here it will be different, like we discussed just now. Summation of F T is actually equal to AT, and summation of Fn equal to MAN. So based on that Newton's second law equation, you need to draw the free body and kinetic diagrams. Okay, second, apply the equation of motion in the anti direction. How to do that? Okay, this is the solution. The anti-coordinate system can be established on the ball at point A, thus at an angle of 45 degrees. If you see here, the chord is not in this parallel line as in this axis X. So that's why I have a curve here. Okay, the curve angle is about 45 degree from this axis. So you need to draw the free body and kinetic diagram based on this figure. Okay, for example, what we understand with free body diagrams, everything on the system that concerned about the force. So whatever the force involved in this system, you have to draw that in the free body diagram. In this case, we know that the ball is actually 10 kilograms, so it has a weight here, like we discussed before. The weight is always pointing downwards due to the gravitational force. And then I have a chord here in which it will trigger the tension. So the tension, if you see, this is the tension is lying on an axis, normal coordinates, normal direction, sorry. So T is in this direction and it is 45 degree. Okay, so here you have to draw not only the body, but you need to indicate which direction is the force is acting on the body. Like this one, T is in this direction and W is in this direction. And don't forget where is the axis pointing at. If you see this one, AT, like like we mentioned in the slide before, I think here. Okay, the tangential direction T is tangent to the path. Okay, tangents mean the slope, usually set as positive. Okay, actually you can set any direction, but usually, because it will ease our process of analyzing the particle itself, set as positive in the direction of motion. Okay, positive in the direction of motion of the particle. If based on this sentence is reflect back our example here, I know that the particle A is moving in this direction, so I will say that my T direction is positive in this direction. Okay, that's why T here is positive in this direction. Okay, so we have analyzed the free body diagram, the particle, the forces acting on the body, and which axis. The same, you need to draw the kinetic diagram. So based on this figure, I have a particle and I know where is the direction of the axis and is pointing towards the curve of the curvature, while T is positive in the direction of the particle. So I know that this is my direction of the motion. So I know that at T, for example at T, the particle will be in this direction. So I need to mention the kinetic equation here, MAT. Before this, in chapter 13.4, sorry. So we just analyze that in terms of either X or Y, MAX or MAY, but this one will be MAT. Okay, we also have the acceleration in normal direction, so always pointing to positive in this direction. So this is what will be my MAN. Okay, very easy. This is very easy. Just free body diagram is concerned about the force, while kinetic diagram is about the motion. Okay, second, you need to apply the equation of motion in the anti directions. Okay, summation of Fn, you need to separate based on this diagram. You need to separate that into equation. Fn equal to MAN. So I have T minus W sine 45. Where do I get T and minus W sine 45? You need to check back your free body diagram. For example, I have said this direction is positive, so I know that T will be positive in this direction. So I need to resolve this into this direction as well, which is this one due to the wake. So in this direction will be negative. I will say I have for W minus W refer to this wake, sine 45, because I want to analyze this direction. So it will be negative in this direction, equal to MAN. Okay. So T minus W sine 45 equal to MAN. Okay, to solve this equation first, we need to solve this equation. We know this is 10 kilograms, so this I have the value for this one. W also I have because I have the mass, so I just need to multiply that with the gravitational force, 9.81 meter per second square. But I don't have AN. How to find AN? Based on this equation that we discussed before, which is AN is the acceleration in normal direction, V square divided by rho. So the V square is moving, the particle is actually moving with 3 meter per second. Okay, 3 meter per second here, it mentioned here. So just put here 3 meter per second divided by 2. Why 2? Because 2 is actually a radius. Doesn't matter if the particle is here or here, because this is the perfect circle. So this one will be 2 as well. So my radius of curvature is actually 2 meter. So I just plug in everything. I will say that I have this value AN. I have this one as well. This one as well. So directly I can get T, the tension, which is in this case 114 Newton. Okay, 114 Newton based on this equation. Okay, now we analyze for summation of Ft in tangential direction equal to MAT. Let's take a look at this free body diagram. I have this will be in this position. This will be positive. If the only force that acting on this line is the wake, so I need to resolve this into W cos 45. But we know that this the W or wake is pointing downwards, so this one will be positive value because it is moving in this direction. If I resolve W, I would say that W is downwards direction, so this one will be positive. So I will have positive W cos 45 equal to MAT. Okay, so I have this value 10 times 9.81. This one also I have 10. Actually I can just cancel down because this is actually mg, but doesn't matter because I just want to find 80 here. Okay, so 80 is this form, this equation 98.1 cos 45 divided by 10, you will get AT equal to 6.94 meter per second square. Okay, this is group problem solving 1. Given 800 kilogram car is traveling over a hill with the shape of a parabola. When the car is at point A, okay, this is my car and this is the parabola equation. Y equal to 20 times 1 minus x squared divided by 6,400 in bracket. So my car is traveling along this curved path. Okay, now when the car is at point A, okay, this is point A, which is 80 meter from here, from the center here. Its V, or we said the velocity, is equal to 9 meter per second and A equal to 3 meter per second square. So you can just neglect the size of the car because we can treat the car as a particle. As long as we know the mass of the car. Okay, so you need to find the resultant normal force and the resultant frictional force exerted on the road at point A by the car. Okay, so the plan, you can treat, like I said just now, treat the car as a particle, because the most important thing when we treat the car as a particle, we just need to know how much is the mass. Okay, then draw its free body and kinetic diagrams. Free body, like we discussed before, only concerned about the force, and kinetic diagram is about the motion, in which direction is the particle will move. So second, apply the equation of motion in the NT directions, normal and tangential directions, because this is concerned about the curved path, it's not a rectilinear motion. And then use calculus to determine the slope and radius of curvature of the path at point A. Okay, this is the solution. First, the NT coordinate system can be established on the car at point A. Okay, you need to identify which is N and T coordinate first. Okay, if you see here, this is my particle traveling at A. I would say that this is my curve. So the NT, like we said before, N or normal direction is always positive, pointing towards the center of curvature. So I would say this is my, for example, this is my curve, this is my curve, so this will be my positive direction in N coordinate system. Okay, where is T? T is the tangent, so means tangent is the slope itself, and it will be positive uh, when we in the direction of the motion. For example, the car or the particle here is traveling along this curve, so this is my direction, so I would say that T, whereas the slope here, will be positive in this direction. Okay, that's why if you see this is my particle, I would say this is my N positive and T is here. Okay, now we analyze about the force. What we need to know, because we are talking about free body diagram here. So where is the force? What kind of force that we have in the acting on the particle itself? So first of all, we know that this is 10 kilogram car. So when I have a mass, I will have the weight. So the weight is always pointing towards the earth, which is downwards direction. So this is just mg, W equal to mg. Okay, the car is not hanging somewhere, means that it is located on a ground. So I would say that the car will have a normal force, which is acting perpendicular to the ground. So for example, at A here, I would say 90° on the ground here will be this direction, and always and direction, the normal force is always pointing outwards. Okay, since the question is actually asking you to find the frictional force, resultant frictional force here, means that in the system itself will be a frictional force. How the frictional force is always what is the mechanism of frictional force? So basically, frictional force will always in the opposite direction of the motion. If you see the car is actually traveling downhill here, so it means that the friction is pointing in this direction, like in this figure F. So it always opposite to the motion. Okay, now we need to analyze the kinetic diagram. You draw the particle and then you just pointing which is the direction of the MAN. The acceleration, the normal acceleration and the tangential acceleration. So the particle will be positive in this direction. Okay, now you need to solve the equation, apply the equation of motion in anti direction. For example, you want to solve summation of Fn equal to MAN. So you need to refer back to your free body diagram, what kind of force that acting on N plane. I would say I have W, the weight, in which you need to resolve that into this direction first, this one and this one. I would say this is pointing positive because I will have weight in this direction. But I need to resolve that because it is inclined, so I need to resolve this based on the inclination angle here, theta. Okay, I also have, because I know that this will be positive in this direction N, so N, the normal force here, is actually acting on this direction, so it will be negative. That's why if you see in the equation of motion, I will say Fn, summation of Fn equal to W cos theta minus N, okay, equal to MAN. MAN is this direction, so it will be positive in this direction. Okay, let's try to solve this. So we know that W is mg and An equal to V square divided by rho. Okay, so substitute everything, the value 800. Oh, sorry, this is 800 kilogram, not 10. I misconfused with the previous example. Okay, 800 times 9.81 cos theta minus N equal to M 800 times An here 9 square divided by rho. So you want to solve this equation, I have three unknowns, N, theta and P, and rho, sorry. So I will say this is my first equation. Okay, now let's solve for AT, summation of Ft equal to MAT. Okay, let's refer back to this free body diagram. T I have in this direction, so I might resolve this in this direction as well. So it will pointing this, so I will have W sine theta positive and minus F, because F is acting on T direction but in opposite direction, so it will be negative, while AT will be positive in this direction. So I will have W sine theta minus F equal to MAT. Okay, substitute all the values. I will have this equation. F equal to 7848 sine theta minus 2000. Right? This is two unknown, f and theta. F and theta. So the question is, can I solve for P? So can I solve for rho here? Okay. Determine rho by differentiating y equal to fx at 10 at x equal to 80 meter. So actually y is given the value of the equation y equal to 20 times 1 minus x squared divided by 6400. So you need to differentiate this and differentiate that again to find rho based on the equation that I present to you before in the slide. So do it one by one. First, dy over dx. So I will have this value, and then I just need to do another second derivative. I will have this one, this value. Once I know this, I just plug in everything inside this equation. I will say that my rho at x equal to 80 meter, because they ask you at x equal to 80 meter, equal to 223.6 meter. So this is the value. Okay. So you have rho now. Okay. So you have rho, you can insert this rho. Now I just have theta and n. How to find theta? Okay, determine theta from the slope of the curve at A. I know that tan theta, which is, let's say I have this triangle. Tan theta is actually dy over dx and then you need to find x equal to 80 meter. Okay, just solve this equation. Dy dx, we know that this is the value. You put that value in this equation, 80 in this equation, and then make that as arctangent, inverse tangent, and then you find theta equal to 26.6 degree. Okay, once you know rho and theta, actually you have eliminate these unknowns, theta, rho, and this one is just theta. So actually you can directly get this and the normal force and F, how much is the frictional force. Okay, from here you just insert everything, you will get N, the normal force equal to 6728 Newton, and I also have frictional force equal to 1140 Newton. Okay, finish this part. Okay, like before, any question that raised in this lecture, you might ask in our another session. Thank you very much.